What is relative humidity? When discussing humidity, one must distinguish between the two terms relative humidity and absolute humidity. This is because air can absorb different amounts of water at different temperature values. In general, the higher the temperature, the more water air can absorb. At each temperature, there is a certain point at which it is no longer possible to add more water to air. This point is known as the saturation point or dew point, since this is the point at which condensate begins to form. In technical systems such as an air conditioning system, it is very important to know how close the humidity contained in air is from the saturation line. In other words, from what point onwards condensation will occur. The amount of water which air can absorb is therefore scaled from 0 to 100% and is known as relative humidity. Relative humidity is therefore a percentile proportion describing the degree to which air is saturated and how close the air condition is to the saturation line. By contrast, absolute humidity describes the precise amount of water contained in air, in grams of water per kilogram of air. So now, what can we say about an air condition with an established temperature, absolute humidity and relative humidity? Let's assume we have a flask containing air at 20 degrees Celsius, 10 grams of water per kilogram of air and 70% relative humidity. For a start, we know that the air is already very humid and can only absorb 30% more humidity. We also know that the air will reach the dew point line if absolute humidity increases by 4.7 grams of water per kilogram of air. And we know that the air in this state will also reach the dew point line if it cools down by at least 6 degrees Celsius. If we now add steam to the flask and increase humidity, mist would then form, followed by condensation as soon as we reach 14.7 grams of water per kilogram of air. Or, alternatively, if we decrease the temperature by 6 degrees Celsius, the air would also reach the saturation line. First mist and then condensate would form.